Hello guys, welcome back to my YouTube channel. So today we are starting off with a new topic, the OSI models. OSI refers to the Open System Interconnection. The OSI model defines a networking framework to implement protocols in 7 layers. Each layer has specific function and provides services to the layer above and below it. Layer 1, the physical layer, example Ethernet. Data transmission. The lowest layer of the OSI reference model is the physical layer. It is responsible for the actual physical connection between the devices. The physical layer contains information in the form of bits. It is responsible for transmitting individual bits from one node to the next. When receiving data, this layer will get the signal received and convert it into zeros and ones and send them to the data link layer, which will put the frame back together. So this was all about the physical layer. Now moving on to the layer 2, data link layer. Example, MAC addresses. The data link layer is responsible for the node-to-node delivery of the messages. The main function of this layer is to make sure data transfer is error-free from node to node to another. Over the physical layer, when the packet arrives in a network, it is the responsibility of the DLL to transmit it to the host using its MAC address. The data link layer is divided into two sublayers: Logic Link Control LLC, Media Access Control MAC. Now let us see the function of the data link layer. Framing, physical addressing, error control, flow control, and access control. Now coming to framing. Framing is the function of the data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attaching special bit patterns to the beginning and end of the frame. Now moving on to the physical addressing. After creating frames, the data link layer address physical address of the sender or receiver in the header of each frame. Error control. The data link layer provides the mechanism of error control in which it detects and retransmit damaged or lost frames. Flow control. The data rate must be constant on both sides, else the data may get corrupted. Thus, control coordinates the amount of data that can be sent before receiving and acknowledgement. Access control. When a signal communication channel is shared by multiple devices, the MAC sublayer of the data link layer helps to determine which device has control over the channel at a given time. So this was all about the data link layer. Next, we have the third layer, network layer, example IP addresses. Routing. The network layer determines the best path for the data transfer through an internetwork. It makes the use of logical addressing such as IP addresses to forward packets. Second, packet forwarding. When the data is ready to be sent, the network layer adds necessary information like the sender's IP address and the receiver's IP address to form a packet. Internet Protocol IP. IP is the primary protocol in the network layer that provides logical addressing and routing services. It enables devices to connect and communicate across networks. So this was all about network layer. The fourth layer, we have the transport layer, example TCP. The transport layer provides services to the application layer and takes services from the network layer. The data in the transport layer is referred to as segments. It is responsible for the end-to-end delivery of the complete message. The transport layer also provides the acknowledgement of the successful data transmission and retransmits the data if an error is found. Reliable data transfer. The transport layer ensures that the data arrives at its destination error-free and in the correct order. TCP is a popular protocol that operates at this layer. Session multiplexing. It enables multiple conversations to be multiplexed onto a single physical link, thereby increasing the utilization of the network resources. So this was all about the layer 4, transport layer. Next, we have the layer 5, session layer. Example, establishing and managing connection. Connection establishment. The session layer is responsible for initiating, maintaining, and terminating dialogues between the devices. Dialogue control. It oversees the orderly exchange of data between the host and deals with issues like half duplex and full duplex operation and dialogue initiation and termination. For example, let us consider a scenario where a user wants to send a message through some Messenger application running in his browser. The messenger here acts as the application layer which provides the user with an interface to create the data. This message or so-called data is compressed, encrypted and converted into bits, that is zeros and ones, so that it can be transmitted. So this was all about session layer. Layer 6 is the presentation layer. Example, data encryption. Data translation. The presentation layer translates the data from the application layer format into a network format and vice versa. It also handles data compression and encryption. Encryption and decryption. It ensures that the data sent by the application layer of one system is readable by the application layer of the another system. Next, we have the data compression. This layer compresses data and encodes it for secure transmission across the network. So this was all about the presentation layer. Layer 7 is the last layer, that is application layer. Example, HTTP. Protocol interaction. The application layer provides network services directly to the user application. It interacts with the software application and sub-communicates the desired user end goals. So this was all about the layer 7 application layer. Now let us see the summary of the OSI model. Layer interaction. Each layer relies on the service of the layer below it. For example, the transport layer relies on the network layer for addressing and routing. Implementing protocols. The OSI model helps in understanding and implementing various networking protocols, ensuring efficient communication between the devices. So we had a brief summary of the OSI model. Conclusion. The OSI model structured approach plays a crucial role in ensuring interoperability and standardization in network communication. Understanding its layer and function is the fundamental for network engineering. If you like my content, please like, share and subscribe to my YouTube channel. Thank you guys.